Hello. But Aya, can you hear me? Because I can't hear you. Okay. I'm not sure, but I can't hear you. I heard something.
Hello.
Oh, yes. Now I can
Are you
hear.
hearing me?
Yes, yes. How are you doing,
Yes.
Aya?
How are you? Alhamdulillah. What about you?
Alhamdulillah. Alhamdulillah. How is Ramadan?
الحمد لله يعني تعديوا أسبوعين بسرعة.
Yeah, yeah. أصلا الوقت يدوز
يس.
دغيا.
ما أنت تويك إحنا في نصف شهر رمضان وما تو الحق حسيت كأنه عادة في صعب. شو أحوي لك أنت سارة؟
Alhamdulillah. We live in life.
لبس إن شاء الله.
آمين يا رب. How about you? Anything
طبعا
new?
الحمد لله. Like usual.
That's great. That's great.
Okay. So if you are ready, we can start.
Yes, please. Can you just put the notebook or slides, whatever you want to call it?
Yes.
Thank you. All right.
Okay. So مرحبا بك. Welcome to our Build AI, the first session with Jide Jesus. The stage is yours, Sarah.
Thank you. Thank you, dear Aya. So, Assalamu alaikum. My name is Star Latif. Today I will be talking about Multimodal Live API. So, just briefly, Gemini, as we all know it by now, I'm sure, is actually Google's LLMs. That is more like multimodal LLM. That means that it handles not only text, it also handles images, it handles videos, it also handles code, it handles anything actually that we can kind of like draw information from and that we humans beings actually can process as well, right? So Gemini has been through different developments. At first, it wasn't called Gemini; it was called Pali, and then it wasn't. It was called actually Palm, and then after that, it changed names from Palm to Gemini, and the Gemini, the UI version that everyone usually knows, actually was called Bard, and then it was changed to Gemini, so they can have the same name everywhere. Also, they had different versions of Gemini. just recently they had something called 1.5 Pro that can process that was multimodal, that is processing video, text, images, etc. And now they have updated their models to the Gemini from Gemini 1.5 to Gemini 2.0, and also they have added something called the Gemini SDK that is kind of like a library that can make it easier for us developers to develop using Gemini, obviously more specifically using the multimodal aspect of Gemini. Also, their Gemini Flash, before it didn't handle multimodal data. It was only able to process text. But now with Gemini Flash, you can actually even process videos, images, etc. And obviously they have something called Imagen or Imagen. I like calling it Imagen. I have no idea why. it's called Imagen. So Imagen has also seen a change from Imagen 2 to Imagen 3, and Imagen 3 has more capabilities. Like before, we could only use it to generate images, but now you can use it to generate images and do what we call inpainting. That is like you can change something specific in the image that you can provide it with. So today I will be exposing the Multimodal Live API using the Gemini SDK. So what is this Multimodal Live API? So on top of the fact that it is multimodal, that is, it can do text-to-text generation, text-to-audio generation, text-to-audio generation, and even like video to audio generation or video to text generation, along with code generation and some other cool stuff that are function call in Google search that we will see below. It's actually its main power, and why we call it the live API is that we can actually interact with the model in a live fashion. That is, you can ask the model to do something right now and it will be able to do it without making you wait for a long time. That wasn't possible with Gemini 1.5 Pro because we could obviously process a lot of modalities, but we still had to wait a little bit more time to get our response because it was much harder for the models to handle the multimodal aspect of our data. But now we can do streaming. That is like we can talk with the model and it can answer us right away with the multimodal aspect, not just with one modality that was text before. So this is the notebook we will be working with. Let me share the link with you here so you can use it as well if you want to. Okay, so the first thing obviously is to install our SDK, the one that has the Gemini model that we'll be working with. So it is called now Google Gemini. Because we're working with Colab, by the way, you can work on this. You can run this notebook in Colab Enterprise, Vertex AI Workbench. You can just click on any of these and you will be able to use it directly. So because we're working on Colab, we'll be running this cell, obviously just authenticating us, kind of like goes to our Google account and then give it some rights of writing and reading information. We import the libraries we will be using. Mainly the ones that that are important for us are these two. So the Gemini one, obviously. And then from the Gemini library, we will be importing things like function declaration, which we'll be using later, as well as Google search for grounding, Live Connect config, the one that we're using specifically for the multimodal live API. The pre-built voice configuration, we will be using it so we can actually, so the model can interact with us using voice or audio. Then there's a speech config, also the same. And then there is tool and tool code execution. So these are just in case we want to call some kind of API that is outside of, I don't know, you might want to call the Google Maps API or the weather API, any kind of API you want to use, or even just use the Google code execution, the one that you might find in AI Studio. That's one as well. And then the voice config is also related to the audio part. So as always, with Google Cloud, you obviously need to provide your credentials, and that is mainly the project ID. And from your project ID, they can, kind of like get all the information they need. So they obviously, you also need, I'm not sure if it's already, if it has already been enabled, but usually I did enable the Vertex AI API from Google Cloud directly by myself, but normally I believe you can authenticate it using this directly as well. But just in case, yeah, you can do it this way by just selecting Vertex AI True. That means that it will be enabling it for you. So one thing I would like to highlight here. So as you can see here, I am actually putting my project ID like this, and I'm sharing my notebook with you. That means that anyone can use this, but it is quite unadvised to do so. So in this kind of case, what we should be doing is that we can use this from google.collab here. So we can kind of like make it as a secret key so that no one can access it. Then we can, add new secret key. We can call it project ID and then paste it here. And then I will kind of like, we can enable it. And then when we want to use this, we can just directly use project ID. So user data.get, obviously instead of secret name, we will be providing this with our project ID. And here we won't have to, we don't have to provide it with anything. We can just put this in a comment and it will work because we already put project ID here in here. So please do this when you're working with Google Cloud, especially if you want to share your Google Colab with someone. It is best that you do not share your project ID, because obviously it is billable. You are paying for everything you're using. So apart from this, so from here, what we'll be doing is that project ID. So what we'll be doing here is that we will be calling the Gemini library, right? And then obviously the Gemini library is going to call, kind of like authenticate us in front of Vertex AI and activate all of the APIs we need so we can access and play around with the model. So we're calling this client because we're going to use it to connect to many services from Vertex AI. So Gemini, as you know, has several different models, right? So there is the Gemini 2.0 Flash experimental, and there's also the Gemini 2.0, Gemini 2, obviously there's also Gemma. So here we can define any of the models that we would like to use. And so yeah, you can use Gemma, you can use Gemini, you can use whichever one you want. Just make sure that you get the right name of the model you want to use. This is how you define the model you would like to use. And then for the Multimodal Live API, before we move in, let's just look at this. So they say that Multimodal Live API is a stateful API that uses WebSockets. So what does this exactly mean? It's actually very simple. So as I told you, one of the things that the Multimodal Live API will be able to provide us with is that we can interact with the model directly using different types of data. That is, we can talk to it in audio format, we can even talk to it in text, we can provide it with documents that has images, text, and tables, and whatever we want, right? So the best thing about the Multimodal Live API is that we can get an answer quickly, more quicker than we used it to do before. We had to wait until the model processes the information. We'll wait more than now. So we can get our information. So what does this stateful API actually mean? A stateful API is very simple. It's that right now, the model, when we interact with it, it will remember our interaction. Obviously, while we are on the session, that is why we are talking to it right now, it will remember what we are talking about. But if we shut down our session, that is, like Google Chrome. If you shut down your Google Chrome, it's not going to remember what you were doing before, right? But if you leave your Google Chrome open, it will remember what you were doing, as might even, kind of like help you kind of like fill the, keep your keys, etc. Keep your keys and all of that available to you at any given time. So this doesn't mean that we can't have history. That is, for example, if you would like to, kind of like your model to remember all of the conversation the user or yourself had with it, you can do that. But right now, as I have understood, it is not yet available in the Multimodal Live API, but it will be available later on. So just remember that in case you want to develop, an application, just remember that history right now is not available. You need to program it yourself or wait until they provide it. So here, let's start with text-to-text generation. So the first things first is that obviously we will be calling the Live Connect config. That is, the Live Connect config is the Multimodal Live API. We are setting the exact answer that we're expecting from the model. So if we're expecting the model to answer us using text, we need to set here text. If we wanted to answer us using audio, we need to set audio here. So async with client AO live.connect. So here we're going to provide the async, the one that is going to send our request to the model, and in asynchronous fashion. We will be providing it with the model ID and then the configuration of the model. And as you can see, the configuration with the model here only has the type of answer we're expecting, which is in the textual format. And then we're providing to the session, as a start, so we can start the conversation. Text input, you can think of it like system instruction. You can even think of it as a prompt. So, and here this is to display just what we provided it. Then we wait, that is, the model receives our request, and after the model receives our request, usually it would wait until something happens, right? So to avoid making it wait endlessly, we add this end of turn true. That means when the model will receive, hello Gemini, are you there? It will stop waiting for more information or text from us, and then it will directly send us its response by using this async for message in session.receive. If message.text, then respond.append message.text, and that is actually just the response of the model. And then obviously it will print its answer using Markdown. So here it is. So input this one here. This is hello Gemini, are you there? And we are printing it using this display. And then response, yes, I am here. What would you like to talk about? Which was received using this section of the code, and obviously printed using this display. Now, I was playing around with it. I wanted, because the Gemini 2.0 Flash actually now handles a couple of, I don't remember the number of languages it can handle, but now it handles, I think it was 30, but yeah, I'm not sure. It handles now a couple of languages all over, and before it was able to answer when I used the Moroccan Darija, but yeah, I still wanted to see if it has improved or not, because even though it can answer, it's still not that good yet. So I just changed the text here. I didn't do anything. I just changed this text from hello Gemini, are you there? To Salam Gemini Rakena. So this is actually like our Darija. I'm not sure if you guys can understand it, but yeah. So this is kind of like the same text, just in Moroccan Darija. And as you can see, it kind of answered the first part in Darija. Obviously, this is not exactly Darija. This is pure Arabic. And then it continued in English. So even though the model kind of like can understand Darija, it's still not that comfortable at answering in Darija. So here it answered us with wa alaikum salam. Is there anything I can help you with today? Meanwhile, before it answered, yes, I am here. What would you like to talk about? And this is something I've actually observed, is that it changes its answer whenever I talk to it in Darija. Although it is the same thing, like, for example, this "Hello Gemini, are you there?" is actually, this is the pure translation of it in Darija, but it gave us a different answer. Yeah, so just if you wanted to try that too. So here, this is another example for text to audio generation. This time we're expecting the model to answer us using audio format. So we will be changing the format from text that we had before in Live Connect config to audio. And now we are specifically choosing a specific voice that it will answer us with. So they have 5, as you can see here, voices that are supported. There is Puck, there is Sharon, there is Cord, there is Fenrir, and there is Audi. And so this Audi actually is a woman. Sharon is a man. I have no idea about the other people. I didn't try them, but I only tried these 2. So as you can see here, we have all kinds of new features. So we can, kind of like just choose the person that we want the voice of. So speech config, we say speech config, voice configuration, pre-built voice configuration, voice name, Audi. So you could obviously change this to anything, and I believe you can even perhaps add your own voice in this phase. So perhaps instead of using pre-built voice configuration, you can use your own or something like that. Didn't try it, but I believe you can definitely do that. So the thing that is going to change in the model, this one doesn't change. We set the model to the model ID that is Gemini Flash Experimental to the 0, obviously. The configuration is just this thing here, the Live Connect configuration with the audio that we choose. Audio, but now because audio data is processed differently from text because it has more parts to it. So here, if message.server content model turn and message server content model turn parts. So this is just like to process actually the audio, and because obviously audio has several parts, so they need to kind of like make sure that we receive the full audio. That's what actually this part of the code does. And obviously displaying audio in Markdown is different from displaying pure text, so this is why this one has changed as well. So here it's the same request. Hello Gemini, are you there? Let's listen.
I'm here. What would you like to talk about?
So as I told you, Audi is a woman. I hope you heard that. Let me repeat it for you.
Yes, I'm here. What would you like to talk about?
So yep. Now
Yes, we are hearing.
Yeah.
Yes, I said we are hearing the voice of Gemini.
Thank you,
Yeah.
thank you. So here I tried once again. I tried once again with Deja. Let's see the disaster. So I told, it's the same thing as I told you. What I wrote here is the same translation, just in Moroccan Deja. So I told it, Salam Gemini Rakhana.
Walya alaykum assalam. I am here. What can I do for you today?
As you can see, the only thing that was supposedly in Darija, obviously it's not Darija, it is Arabic, is the wa alaykum assalam. And as you can see, its accent is extremely bad. So we might want to, if you're thinking of using Gemini with your, kind of like mother tongue, just be mindful of the fact that it will be extremely awkward. So if you don't want people to laugh, avoid using it until they improve it, or just train the model further. So if we use Sharon, obviously we're not going to change anything in the code. We're just going to use the voice name, right? So here we can choose Sharon, or you can use any of these people here. Obviously, like I said, I'm sure you can actually use your own, but I haven't tried it. Okay, let's try Sharon now.
Walya alaykum assalam. I am here.
Oh, no,
What can I do for you today?
I chose the wrong audio. This audio.
I am here. How can I help you today?
As you can see, Sharon is a man, but the answer is still the same. Okay, let's try text to audio conversation. So this time, we're going to be sending textual requests, we're going to actually be talking to the models actively. Like when you're talking to it when you're in AI Studio or the typical Gemini UI interface. So here we can do this too, and obviously because this is going to be a back and forth conversation, the code is going to change a little bit, so that it can allow us to do this interaction. Once again, we're expecting the model to answer us using audio, and if you can check out here, we did not specify the actual voice that is going to answer us. So here we're just picking the default one. But if you want, for example, Sharon specifically or Audi, you can just change it here. Like we did before, copy, paste, don't change anything. So let's see the code so we can interact with it actively. That is, we can have a back and forth conversation. So we still have the async diff main. So here we're just obviously defining a main. So we can define the kind of like, we can call the function when we finish defining all the other functions that we need. So receives known, that's normal. So here, async with client.io live connect, we still set in the same thing. We just have something called send now. And in this send, we're specifying something. Obviously, we're requesting the input from the user, that is us. And then we lower that text. And after that, so unless the user, which is us, interacting with the model, unless we put queue, quit, or exit, we can continue the conversation, and the model will still wait for us to kind of like provide it with further instructions. Otherwise, if we put queue, quit, or exit, that means that the model will stop interacting with us, and obviously the session, all of the session will be interrupted. And remember, if you interrupt the session, the model does not have something called history, so it won't remember your conversation. When you're in the conversation, it remembers what you talked about. If you quit the conversation, there is no remembering. So here, obviously, we will send it the answer, and then after that, after we send the answer out, or our first answer, our first input, is going obviously to shut down that so that it can go and then call the model so that it can give us its answer. That is going to be defined in this section, which is called receive. So async def receive, receives known. I mean, kind of like returns known. But here we define the audio data. Obviously, we're kind of like taking the same code we had in the audio until here, right? Same one, copy paste, no changes. Just this time, if message.server.content.turned complete, that is if the Gemini finished generating the audio it wanted to generate, we're going to display that audio. That is, we're going to use the response, then display the audio, and the audio is same like we did before, audio numpy.concatenate audio data, rate of 24,000, and then autoplay true. That is it, that we don't have to press the play button, it will play by itself. Then we break and then we return. And this is actually, in reality, this is the new thing that was added apart from this. When we can choose to quit, this is actually the thing that was added so that we can keep ourselves in the conversation until we decide to quit. So while true, if not, await send break, await receive. So as long as we do not receive this, quit or exit, we can keep the conversation going. And to start the conversation, we just have to call await main. So let me just, so actually like tried a couple of things in Darija. So I will translate, I will read it first in Darija and then translate, just in case you guys fail to kind of like get it. Moroccan Darija is a bit different from the other Arabic Darijas, I don't know why. Anyway, so the input I requested is so I asked it, can you talk in Darija? Here's its answer.
Waka net kalem be darija ila be I te I شنو بغيتي تعرف ولا نهضروا فيه؟
As you can see, it looks more like Chinese than actual Moroccan Darija, but whatever. So what it tried to say is that واخا واش نعرف واش زعما واش can I like speak in Darija or not? So واش نعرف ندوي بالدارجة ولا لا? And then suddenly it spoke fluently in Darija, which is quite creepy.
بي اي تي اي شنو بغيتي تعرف ولا نهضروا فيه؟
So as you can see, even the tone of the voice actually changed. So it said, شنو تعرفنا شنو تعرفنا شنو تبغينا ندوي فيه. I think that's what it said. Let me just see.
اي شنو بغيتي تعرف ولا نهضروا فيه؟
Yes. شنو بغيتي تعرف ونهضروا فيه. So it's like this is actually I'm sure this is something that was taken from the actual training data, the original training data. So it took perhaps someone's voice and chose that because it resonated with the answer, with the question that I asked, and then answered that bit in the later part. But the first one, it tried to answer by itself first. Anyway, it failed all over. So as you can see here, I answered it. Darishtik is very funny. So I thought that its Darija is very funny. شو تتعرف على المغرب? So I asked it, what do you know about Morocco? Here is its answer.
ها 3 أرفك قاعد تقولها can't 3 عالم. Bessa, Morocco is a fascinating country. I know it has a rich history, with influences from Berber, Arab, and European cultures. I know about the bustling souks, the beautiful mosques, and the delicious tagine. Plus, the Sahara Desert is breathtaking.
Please don't ask me what it said in the first part in Darija. I have no idea what it tried to say. So I actually told it, it seems like you can't help but answer in English. Thank you. Here is its answer.
You're right, switching completely to Darija is still a work in progress for me. Is there something specific about Morocco you'd like to discuss? I'll do my best to respond in Darija, or at least understand you.
So
You're right,
as you can see here, I still asked it some more in Darija. So what I told it is تتعرف كي تيصوبوا الرغيف ديال البصلة. So I actually asked it if it knows how to prepare a very specific cement type that is actually filled with onions. So yeah, we call them rghaif. That is actually just some cement, but anyway, it's another form because it changes the content changes, it changes the name. So here's its answer.
RG Hayef Dial Besla. Walk, I'm not a chef, I know the basics.
As you can see, it tried to kind of like read the the letters instead of actually reading it as we would read it. So instead of saying rghaif, it said RGHAYEF ديال البصلة. And then it's going to give us the recipe.
The dough is made from flour, water, and salt, kneaded well, and then flattened into thin layers. You spread a mixture of onions, spices, and oil between the layers, fold it up, and cook it in a pan until golden brown. Would you like me to find you a recipe, maybe with more details?
So that's it. And then obviously I quit because I just wanted to show you an example. You can obviously do this in any kind of language. I do highly invite you to try out a new Tunisian language. Perhaps perhaps it will give you something interesting. So let's check out the function calling. So let's say, for example, you actually want to call some kind of API outside of the Google APIs, perhaps that you have, or just you want to structure the way the model answers you back, right? You can use that. You can do that using function declaration. So usually function declaration is not only used to so actually it's used to structure the way we expect the model to answer us back. And it is very much used when we use tools. So here we're not using right now any tool or API, but if you're using an API or tool and you want a specific way to output that information to your users, you might want to use function declaration on top, obviously, of the API call that you will be making. So here in the function declaration, we're just requesting it to output weather information in a specific way. So as you can see here, we give it the name of the function, get current weather. We give it a description of the function, get current weather in the given location, and then we give it the parameters. That is the way we want it to answer. So as you can see, we want it to answer in a JSON fashion. So parameters are type object, properties, location, type string. And nothing changes for the Live Connect configuration apart from giving tools this tool thing, and then function declarations get current weather. This is the thing that changes in the Live Connect config. Apart from that, everything is similar to how we, actually defined this before, kind of like interacted with the live, the multimodal live API. Obviously, we changed the prompt request, whatever we want to call it, get the current weather in Santa Clara, San Jose, and Mountain View. The model knows to call the tool by using this part of the code. So if message.tool call, for function call in message.tool call function calls display the function call. So this is the second change that we did. Apart from that, everything is similar to before. So when we run this cell, we can see that as input, obviously, we have the request. Prompt, you can call it whatever you want. Get the current weather in Santa Clara, San Jose, and Mountain View. Function call ID. So because we give it 3 different locations, obviously, we will be having 3 different function calls. The first one is for Santa Clara. So ID known, arguments, location receives Santa Clara. Because in here, we just said in the given location. So this is the actual variable or parameter that our function will be taking. So Santa Clara, San Jose, and Mountain View, and a call for each one of them. This is just simulating the function call. That is, we do not get any answer. As you can see here, there is nowhere in this part we are expecting a response. We're just requesting it to print the function call. That means whenever it is actually calling the function to print the call for us. Now, let's see a way to kind of like see the answer from this function call. So another way, what we're going to see now is another tool called code execution. Same thing as function call. The only thing that is going to change is obviously the tool that we're going to call, the name of it. So the name of it here, we because this is a specific thing to Google, Gemini or Gemini SDK, whatever we want to call it. So they have it already defined. So we call this like this. We're expecting a textual response. For the tools tool, code execution receives tool code execution. This is a library they already defined. So we don't need to define it like we did in here for the function declaration. So for the text input, we're changing the request, the prompt, whatever we want to call it. So write code to calculate the 15 Fibonacci number, then find the nearest palindrome to it. And what actually this thing will be doing is that on top of actually writing the code, it is going to execute the code and give us the actual answer. This is pretty powerful, especially if you want to, I don't know, you have some kind of data, you want to do some calculations on it, or you want actually the AI to draft a code to do the calculations for you. You can request that from AI, and then you can get just the answer right away instead of having to copy paste the code in some IDE to get the answer. You can obviously even test if the function works well or not using this thing as well. So not much changes here apart from this part here. So for part image, the server content.model_turn.parse, obviously, because here we're going to be generating a couple of lines. So we need to keep track of all of those lines. And then for the display, we're going to display the code in a way that is readable by Markdown. And because this is Python code, we're using this thing for Markdown. So py, and then part.executable code, and then obviously we print the answer. So write code to calculate the 15 Fibonacci number, then find the nearest palindrome to it. As you can see here, it is giving us the Fibonacci function along with the palindrome and the nearest palindrome. So these are all functions. And then it's going to call Fibonacci. The Fibonacci normally, as you can see here, we requested it to calculate the 15 Fibonacci number. So we're calling the function Fibonacci. We're giving it as parameter 15. So it's going to print the answer for us. So the 15th Fibonacci number is Fib15. So this thing here, the answer. Find the nearest palindrome. So this is like still the code, right? Still within the code so that we can get these things printed by the model. So this is the response of the model. Obviously, the model is the one that provided us with the executable code. I did not write the code. Then this is the response, obviously, after executing the code that it has provided us. So I can do that. Here's the plan. It's obviously explaining how it's going to do this. Then it is calling the code, as you can see here. And then it is executing the code. This code defines 3 functions. To check if a number is a palindrome, nearest palindrome, to find the nearest palindrome to a given number. The code then calculates the 15 Fibonacci number and finds the nearest palindrome to it. Let's execute this and get the result. So this is where it is executing the code. It has written itself. And then this is the actual answer. Now, let's say, for example, we want to do what they call some grounding. But this isn't exactly grounding, but this is just like if we want to use another tool called Google Search. So Google Search tool lets the model conduct Google searches. For example, try asking it about events that are too recent to be in the training data, right? What is going to change? Just the name of the tool we're calling. So tools, tool, Google Search receives Google Search. Anything else that is going to change? Actually, nothing. We're just going to get rid of anything actually that was added. You know, before in the model, before when we wanted to execute code, we had different parts. So we needed to code that within the async function, but now we're just getting one answer straight away. So we're going back to the code we had at the start. So nothing really changes here, apart obviously from the request. So the request is tell me about the largest earthquake in California the week of December 5, 2024. So its answer was the largest earthquake in California during the week of December 5, 2024 is a magnitude 7.0 earthquake. As you can see, it answered that straight away. Obviously, using Google Search, seeing as normally this shouldn't be in the data that it was trained on. Now, what if, what if you want to mix text to audio conversation with Google Search? I don't know. You want to have a conversation with it like we did before and make it answer you based on Google, facts and not just facts it has been trained on. Because usually if you rely on its fact that it has been trained on, it will most likely hallucinate. So I didn't do anything here, actually. I just called the same thing we had before and recalled the same function we had when we did the back and forth conversation. I didn't change anything in that code. Just copy pasted, just added the tool, and then copy pasted the the function or the piece of code that did the back and forth conversation. And then obviously I used await main to call all of this beautiful code so it can be executed. Then I actually asked it, what is the latest paper around drag? It gave me a really long answer, as you can see.
There's been a lot of recent activity in retrieval augmented generation, RAG research. Here's a summary of some of the latest trends and papers. Key trends.
To not bore you, I'm not going to listen to all of this, but let's check this answer that was actually much more. I wanted to test if it really will be giving me something out of Google search instead of answering based on its own information. Because with the papers and drag, it gave me pretty standard answer. I didn't like that. So let's see with this one. So it gives them suggestion of great agentic AI tools along with their links, ones that were released in January 2025 or after. Gemini 2.0 was actually trained way before January 2025. So normally it shouldn't have any information around 2025. So it will be obliged to actually go get information from Google search. So let's hear its answer.
Here are a few agentic AI tools released in January 2025, based on my search. Swimlane's Hero, an AI security operations, SecOps, companion that suggests next steps and answers complex questions. OpenAI's Operator, an AI agent that can interact with websites to perform tasks like form filling and ordering groceries. It is available to ChatGPT Pro users in the US Gemini 2.0 Flash, a performance upgrade to the Gemini app, delivering faster responses and stronger performance. Google Cloud's Automotive AI agent. Arriving from Mercedes-Benz, this agent allows drivers to have natural conversations while driving. Small Agents, a library for creating code-centric AI agents.
As you can see, it provided me with a couple of them. By the way, it's not speeding, it's me who sped up this, so you can go back and give it normal. And let's go back.
Agents write actions in code. Agent workflow in Llama Index. A system that sits atop Llama Index's work.
And all actually of the ones that it mentioned are actually and has been just recently released. So we can be sure that it's giving us the latest information, obviously using the Google search. By the way, there are a couple of amazing other things you can do with Multimodal Live API, and here are all the information you might need. You can even check out this real-time retrieved augmented generation using the Multimodal Live API with Gemini. I actually even tried with the web application. I wanted to show it to you guys. I will show it to you, but the problem is that I'm not sure why it didn't work for me. I did everything they requested here. I followed all of these steps, but whenever I click on connect, it never connects. I'm not sure what the issue is because I have followed the step as it is. I might still try to debug it this time using this Cloud Run thing, because I tried this setup in Cloud Shell. I tried locally, it didn't work. But yeah, I just wanted to show it to you in case you guys were thinking of developing, an app. This might be a great framework or a great POC, proof of concept, something you can start with just to test and see if it works for you before developing a full-fledged app. That's it from my side. Thank you very much. If you have any questions for me, please let me know.
Thank you, Sarah. We are waiting for the questions. Sino, for the platform, we call it in Tunisia when something like work in a bad way or didn't work. Ramadan.
In Ramadan.
Yes, maybe بعد رمضان يخدم شيء.
You never know.
Yes. Okay. So we have a question. How do I know which model to use for a specific task?
Please use Gemini 2.0 Flash. Right now, just use Gemini 2.0 Flash experimental. It has everything. Before, we were obliged to use Gemini 1.5 Pro, which billed more, obviously. And it was, it took more time because it really did process the information from start to finish, and it gave a better answer, but it took a long time, and it wasn't available with the Gemini 1.5 Flash. The multimodal aspect, that is, processing video, text, audio, whatever we wanted. But this Gemini 2.0 Flash is a real amazing thing. It can help us quite quickly process all of this information. So it's, it's amazing. And it's obviously it's less when it comes to the bills. It is less, let me check how much it is. Yeah, let me show this to you so you can see it. Share this tab instead. You can get all the information around billing just from AI Studio Google. So as you can see here, we have all kind of, information around that. So Gemini 2.0 Pro experimental, as you can see here, you can see all of its bills. So rate limits, latency, how much it processes, because this is obviously experimental. It is not available in production, so there's no billing. But if we check Gemini 2.0.flash, as you can see here, its output is $0.40 for output, and for input it's $0.10. So it processes 10,000 lines of code, calls to natively like search, stream images in video real time. So this is just if you want to get the exact information you might need. Let me see, for 1.5 Pro, oh my God, as you can see here, it was $5 for output, less than or equal to 128K tokens, and for input, $1.25. So as you can see, Gemini 1.5 Pro, which used actually to handle all of the multimodal processing, was much expensive than the new Flash 2.0, which still handles all of the multimodal right now. It means it can do the job that Gemini 1.5 Pro used it to do, but faster and in less expensive ways. So if you're doing something that requires a lot of thinking and understanding, like it's like when humans, when they need to solve a math problem, they need more focus. So if you need higher focus, higher concentration, more intelligence, please use the Pro version. If you need just conversations, normal conversations like these ones, or something that doesn't require a lot of thinking or math solving, math problem solving or heavy logic, use Gemini 2.0 Flash. That's my advice. Sorry for interrupting you, Aya.
No, thank you for this insightful information. Yes. Sinon, we have another question from Ibtisam. What best practices do you recommend for optimizing API calls to Gemini, particularly for latency-sensitive applications?
Okay.
Okay, and still apart from this question, how do you balance API usage, cost efficiency, and response quality at scale?
Okay, so from what I understood from people that build applications in using LLMs, they have an interesting strategy that I really like. So what they do is that they use less expensive LLMs, right? Generic ones, for example, GPT-3 I don't know, GPT-1 dot something, right? Just the lowest, the first GPT. They use it for normal conversations, right? Anything that doesn't require a lot of thinking, a lot of processing information. For example, you do not need to use multimodal, right? Use the most least expensive LLM to do that. So what I mean by this is that you use for each part a specific LLM, and only use an LLM that has higher capabilities when you actually do need those higher capabilities, right? So if you don't need it, shut it down. Don't use it. Don't let yourself get billed for it. When you need, I don't know, higher quality responses, obviously in this kind of case, even the application that you're developing or the service that you're giving to your users, you're going to request they pay more. And in this kind of case, obviously you will have to be providing and using the best in the market, right? So that is, for example, Gemini 2.0 Pro, for example. But that is, as I said, only use what you need based on the needs you have right now. And use code, obviously, like, programming, to kind of like know when to call a specific LLM for a specific task that can handle the complexity that is requested from that task. Use as much as you can function calling. Use as much as you can control your model's answers, control what you get from the user, so that the user doesn't ask some outside of the box question and gets you billed for something that has nothing to do with the service you are providing. So this is like I hope I have been able to kind of like answer your question. Use a Flash or the lightweight models or lightweight LLMs if you need something that will answer quickly. For example, Gemini 2.0 Flash is quite amazing at answering quickly and even processing multimodal data, right? So you can use this. It's less, obviously, it's even less expensive, which is amazing. But yeah, anything else?
Okay, yes, we still have another question. Sino, thank you for your
You're
response.
welcome. You're welcome. You're welcome.
Okay, our participants say thank you to you, Sarah.
You're welcome. Oh yes,
Okay,
for
so
Miriam. Yeah, go ahead.
yes,
Go
we have
ahead,
a
Aya.
question from Mariam. How do I improve the results or response from the API?
Okay. So the best thing to do is to, I think you already know the answer. You need to do prompt engineering. And prompt engineering for developers is not prompt engineering for marketers or whatever you want to call it. So for developers, actually, we do something called instruction tuning, right? Or instructions. So whenever you have a system, the first thing to do is ask yourself, how would you as a human do that task, right? Explain, write that task how you would do it yourself in a step-by-step fashion. Then use that as instructions for the model. That will reduce hallucination and improve your actual results. Because what happens is that when you ask the model to do something generally, like, I don't know, do a summary of a book, right? There are a couple of ways to do a summary, even for human beings, right? We have different ways to do summaries. There are some people who would only mention the names, right? And then the most marking events. There are some people that would not only include the events and also like key names, but also they would include key emotion, right? So there are different ways to do the same task, even for human beings. So reduce this thousand of options by providing your model the exact steps of how you'd like it to do the job. If you do that, you will be improving the API's answers, and you will obviously be reducing the time it will take to do the task as well.
Thank you, Sarah.
You're welcome.
Sino, we have another question from Ikram. How does the Multimodal Life API handle different input modalities? And what are the best practices for optimizing responses when combining text, image, and audio inputs?
All right. So this is this is an interesting question. This is kind of like a whole expertise, but I will try to explain it in a couple of words. Okay. So for the multimodal, you have to understand when it comes to multimodal AI, what we do is that we actually have components in our model that are specific to every modality. Let's say, for example, I have text. I have a component in my model that will translate the text to numbers. We will call them embeddings, and from those embeddings, we take them as part of the things that we will be processing by the big model that will be processing. Let's call it the LLM that will be processing all of the information that we're extracting, right? We have one for image, we have one for text, we have one for video, we have one for, I don't know, if you're using geospatial data. So we have one for every one of these. We have kind of like a module specific that extracts information, transform them into something that the model can understand. Let's call them embeddings. Technically speaking, embeddings are just numbers. So if we had text, they will be transformed into numbers that are meaningful for the model. And then we gather all of this information extracted from these different modalities, and then we gather them together. So in this gather them together, we call this product fusion. So in this fusion, there are different ways to fuse information, right? So what are the best practices for optimizing responses when combining text, image, and audio inputs? This is another research field in the same area, where actually we're trying. We still haven't achieved that. We're still not successful yet in this aspect. We're trying to align every one of these multimodal information. Let's say, for example, like right now, you are seeing me talking, right? So there is a huge challenge in just like me, for example, opening my mouth like this, and then let's say, for example, I'm going to say ah, just aligning the image of me opening my mouth, saying ah, and then having the audio say ah, right, landing on the same piece of audio that is, in match with the image, and then perhaps in the video landing on the same moment when I'm opening my mouth, and then obviously showing myself opening my mouth. So this is a huge challenge in multimodality, and this is actually what researchers are doing their best trying to kind of like figure out the trick for. But technically speaking, if you want to optimize responses when you're combining all of these information, you need to make sure that every one of these modalities are complementary and they talk about the same thing. What does that mean? If I am talking about the weather, the video needs to talk about the weather. The images need to be related to the weather. The text need to be talking about the weather, right? So they need all to be kind of like talking about the same subject, but obviously every one of them is providing different information. That's it.
Thank
I
you,
hope I get
Sarah.
it.
Thank you. Sino, we have two other questions from Nermi. How does Gemini compare to other AI models like GPT-4, Claude, or Mistral?
Well, everyone is saying their model is the best. Gemini is doing that too, obviously. So they say that 2.0 is beating all of the benchmarks, as always. But from my understanding, from my own point of view, I like to think of it this way. Every one of these LLMs has a specific thing they're really good at. So for example, I use Gemini for my case. I use Gemini for research things or anything that has scientific tone or scientific principles. I use Gemini for it. For example, I would use GPT, ChatGPT, GPT-4, whatever we want to call it, for things that have interaction, emotions, right? Something that requires creativity, things like that. I would use Claude, and then this is what I heard people using Claude for, usually for marketing, for business things like copywriting, marketing, writing ads, kind of like doing things that are business specific. And also for code, I heard that it has amazing capabilities when it comes to code. So for Mistral, I have never really used it so far, but I do think that you would use Mistral if you actually want something that is more kind of like accurate and faster. So that's obviously what I would be using Mistral for. And obviously, if I am thinking of using open source instead of actually having to pay to kind of like talk to these models.
Thank you, Sarah, for your response. Another question. How can I optimize Gemini's response using RAG techniques?
Well, you actually asked the question and answered the answer as well. So RAG is a data technique that improves and optimizes Gemini's responses. So let's think about it this way. Let's say you're actually using RAG with Gemini, and if I understood correctly, what you want to do is kind of like improve even further the actual answers, right? So just remember, your actual documents that you're using for this RAG, they need to cover everything that you need, and always make sure that the model visits the actual reports or whatever documents that you're providing it and answer based on those documents. And for example, what I have seen people do is that they use different LLMs. So, like, I don't know, you would use Gemini, you would use Mistral, GPT-4, for example. They would be interacting with the same RAG, this is with the same database that you have, and then you would kind of like get the aggregation or kind of like the average of all of their answers, so that you might reduce as much as possible hallucination. But in this kind of case, obviously, it is expensive. So the best thing to do is to improve the other things, like improve the embedding, improve the chunking, improve the way your documents are stored in vector databases. So improve the other sections of the RAG, so that you can improve and optimize all of your responses from Gemini. But what I would say is that avoid using Gemini, leave it as a last resort. Only, for example, if it's an answer that really requires a lot of kind of like explanation or anything, that needs to make things easier or much more accessible to the user, then you should use Gemini. Otherwise, just use simple programming, right? Use the way you would program an application, and just use similarity search like you would do usually for an LLM with RAG, but do it without the LLM, right? Do what you would do for the LLM with RAG, but without actually using the LLM. Like, do the similarity search, extract this information, and all of that, but only answer using LLMs when you really need a way to simplify information or make it much more accessible to your user.
Okay, that's good. Thank you. Sinon, Mirin say thank you.
You're welcome.
Also, Nermin say thank you.
Thank you.
Yes. We have another question. Okay, this is not about Gemini. How can I become a GDE? I think this is another session.
Yeah. So actually, it's very simple, and yet it is actually very challenging. So to become a GDE, the first thing is that you need obviously to be an expert in a Google category. So for right now, for AI, before we use it to be specifically specific experts in a specific technology. For example, for myself, I am a GDE, but my actual specialization, the one I applied with, was TensorFlow Core, right? But right now there's generative AI, obviously all of Gemini's things related. There is what else? Obviously there are people in Keras, there are others in Kaggle. So there are different kind of like areas where you can become a GDE. So just choose the area where you want to be an expert at: Cloud, Kaggle, Keras. I'm not sure TensorFlow is still there, but I think it is still there. But anyway, I'm not sure anymore, right? What I know is that they're interested in generative AI experts. Obviously, they're interested in Kaggle experts as well, and kind of like cloud experts as well. Cloud and AI experts are amazing, cool. Those are highly sought after everywhere. So kind of like choose the area you want to specialize in, and then start contributing in that area. Work on open source projects, give talks around that area, share your knowledge with your community, teach them things, write blog posts, talk about your knowledge, do videos in YouTube explaining your expertise. So that's actually kind of like what you need to do. Just be highly active in your community. And then obviously you can then and be experts and actual experts in what you're applying for. And that's it. Actually, there's nothing else. And you apply, someone recommends you either from Google or one of the GDEs that is closest to the area you are an expertise in, recommends you. And when they recommend you, you go through the interviewing process. And that's it. There's nothing else, actually.
That's good. Sinon, Marzouk said merci. Yassine also said thank you and good job.
Thank you.
But I think that's all for the questions. Also, everything is easy. Said thank you very much.
You're welcome. Thank you. Thank you to all of you.
Yeah. Thank you so much, Sarah. This is really was an insightful session.
You're welcome.
I would like to thank you for this session, and
well, thank you. That's cute.
Thank you. Yes, I like GIFs. Voilà.
Thank you.
Thank you. That's it for me. So if you want to say something else.
Oh, there's nothing for me to say apart. Thank you, everyone. I mean, thank you for the invitation. You know, Jesus and also Aya, thank you for hosting today's session. It was, it was really a pleasure to be here with all of you. And thank you all for all the questions. I really like it when there are questions. I don't like it when I comment and there is no question. I feel like I didn't do my job properly.
No, you did it very well.
Thank you.
Thank you so much. Also, the participants want to say thank you.
Thank you, everyone. Thank you. I hope you have an amazing end of Ramadan. After all, there is not much time. So please take care, all of you. And Ramadan Mubarak.
Thank you, Sarah. Thank you all. Ramadan Mubarak. And see you, inshallah, in other sessions with us, inshallah.
See you, inshallah. Take care, everyone. Tallahu liya fi raskum.
Thank you. Thank you so much.